Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Look and Whisper by Lithium Ion and Holtz and Adam. Holtz and Adam. Holtz and Adam. I'm not sure if it's a moniker or if it's two people actually there for Holtz and Adam. Obviously, Lithium Ion and Holtz and Adam are separate setters. So, anyways, let's get to the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. Adjacent digits along a green German whisper line must differ by at least 5. So, for example, if this were, say, a 3 here, this would have to be an 8 or a 9, because the only digits which are 5 or more away from 3 are 8 and 9. And I will be calling them Whisper 5 lines because a setter came up with that naming convention, and I thought it made a lot of sense because it's very more easily extensible. Both digits, which can be equal on the endpoints of the green line, form a look and say clue. For example, if, the digits on both endpoints of a line are 4 and 3, then the digit 3 has to appear exactly 4 times on this line, and the digit 4 has to appear exactly 3 times on the line. Okay, that makes sense. Because if you... Right, because it works both ways, right? For the endpoints for 4 and 3, 4 must appear 3 times, because you have the 4 appearing 3 times, and then you must look at it the other way, which is the 3 must appear 4 times on the line. And the line that starts in row 2, column 6, ends in row 2, column 8. Okay. That means the line is this way, and then we have a different line going over here. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so this is 5 in length, and we can only have 2 duplicates at most on this line. So these are both going to have to be low. So this is low, this is low, this is low, and we can have 1 duplicate here, obviously, and we can have 2. So this must be a 2 here, because we have to have 2 ones and 1 2 as possibilities. So this is 2 and that's 1. That's interesting. In this box, we can only have, at most, we could have 4 duplicates at most. So these all have to be low digits here, which is next to a high digit. And you'll alternate between low and high digits on a Whisper 5 line in normal Sudoku. And if you want to know why, you can go to one of my Learn How to Sudoku puzzles with the Whisper 5 line on it, and it will describe why that is. This also has 1, 2, 3, 4. This only goes through 4 boxes. So therefore, you can have at most 4 duplicates here. So this also has to be a low-high pair. So this is low, this is high, this is low, we have high here, these are low, and this has to be a high. Okay, so these are high also. Well, where's the 5 in row 1? It has to be here. And 5s can never appear on a Whisper 5 line because if you subtract 5 or more from 5, you get 0 or less. If you get if you add 5 or more to 5, you get 10 or more, none of which are digits. So, this is 1, 2, 3, 4. So 1, 2, or 3 is possible as these endpoints. So they're next to high digits, which are next to a low digit. Well, you can't have three. I guess you could have 3 3s here. Huh. How many digits? So this is 1 box, 2, 3, 4, 5, 6, 7. So this could be 7 boxes. In this box, in this upper left-hand box, box 1, we are guaranteed one of these is low, one of these is high. We don't know which is which. So this must be guaranteed 1 low and 1 high, which means we have 4 lows already in column 1. So this can't be low, it's high because we can't have the 5 there either. Let's just choose random colors, and we'll make it orange and yellow, and we'll see how the designation goes. Orange, yellow, orange, yellow, orange, yellow, orange, yellow, and we can do this because we know we alternate between, again, high and low digits on a Whisper 5 line. Yellow, and then this is orange. So technically, we could have 7, 6 here at the ends. That's possible. Can we, though? Okay. So assume orange is high. That means we have 6 7s and 7 6s on this line. Can we actually have 7 6s on this line? The answer is no. I guess it could be technically 6 and 6, though. Or 7 and 7. That is possible. Okay. Well, this is guaranteed to be 3 or 4. Because we don't have 1 or 2 available. This is guaranteed to be 3 or 4. This is between 2 unique digits on a Whisper 5 line, so it's 1, 2, or 3. Same with this is 1, 2, or 3. And this has to be 1 through 4 here. This can't be 3 or 4. One cannot appear multiple times on this line because this can't be 1, that can't be 1. We can only have 1, 1 here, and this can't be 1. So this can never be 1 there. This could be 3 and 3. It could technically be 2 and 1 also here. We don't know. Can this actually have 4 4s on this line? The answer is no. Because we have a low digit here, a low digit here, and a low digit in one of those 3. So this cannot be 4 here. So this has to be 2 or 3. This could obviously be 2, 3, or 4. This could be 1 or through 3 here. It cannot be 4. This digit is, well, we don't have any explanation. So this could technically be 4. 1 through 4 here. This is between 2 unique digits on a Whisper 5 line, so it's 1, 2, or 3. Same with that. It cannot be 1. It can't. This is next to 2 unique digits on a Whisper 5 line. And again, the ends cannot be 4 because we can't have 4 of the same digit anywhere in this line. So this is 2 or 3 as a pair, which eliminates 2 and 3 in the rest of the row. So this can't be 2 or 3, it's 4, which means 4 appears on this line 4 times. Well, the only places where you can appear 4 on this line is here, here, and here. That forces this to be next to 9 on the rest of that's next to it for the cells that are next to it on the 4 on this whisper 5 line. So that's 9. Okay. So that gives us all the 4s here. This digit technically could be a 4. We don't know. 1 again can only appear once. Oh, this could be 4. 1. Never mind. Remaining digits in row 1. Well, obviously this is a 5. 6 cannot be next to the 2 and 3. In fact, since this is next to 2 and 3 here, this must be an 8 because it can't be 9. Therefore, this becomes a 6-7 pair. 6 cannot be next to 2 on a whisper 5 line, so this is 6 here, that's 7. This is next to 2 unique digits on a whisper 5 line, and it can't be 7 or 9, so this must be 8. Whereas 8 in box 3 can't be here anymore, so 8 has to be there. That leaves us a 3-5 pair remaining in box 3, which eliminates 3 and 5 in the rest of the column, so this can't be 3. That can't be 3. This must be a high digit and a 6. That means the high digit here has to be 7, and the 7 can only be next to 1 or 2 on the whisper 5 line. So we have a 1, 2, 7 triplet in box 6, which eliminates 1, 2, 7 in the rest of the box. So this is 3, 5 here, 3, 5 there. This digit, okay. What you cannot have on this line is well, that's not true. No, is 2 6s. Because if you try to have 6 here, 6 here, you have 1 6 here at most. You could have 1 6 here. You could have 1 6 6 6 6 6. But the problem is this can't be 6 because it's next to 2 unique digits on a whisper 5 line. And this can't be 6 because of 6 in the box here. So either at the end, this has to be 7 here, or this is a 3 being there. Because that's the only low possible left here, if we want this to be a low. So we could have 7 7s here. Or, and this can't be 4 because of 4 in the row. We could have 1, 2, or 3 here. We don't know. Okay. If these are high, they would all have to be, we have to have 7 7s available. Well, that would be 1, 2, 3, 4, 5, 6, and 7. And if the yellows were low, it'd have to be 1, 2 as a pair. Well, this can't be 1 because of 1 in the column, so that would be 2. That would be 1 there. This would be 1 or 2. This would be 1 or 2. This, well, actually, it could be 1, 2, or 3 here because this doesn't have to be a 7. It could be 6 or it could be 8 here. Can't be 9 because of 9 in the row. So if this is 7, this could be 1, 2, or 3 here. This is 7, it's next to 1 or 2, next to 1 or 2. Okay, so those are possible ones. These have to be 1, 2, or 3 because we can only have at most 1, 2, or 3 available. 3 of the same digit on this line at most. Well, we have a 1, 2, 3 triplet now in row 5, which eliminates 1, 2, and 3 in the rest of the row. So this cannot be 1 or 2. It's 7, which means the oranges have to be high, and the yellows do have to be low. Well, we have to have 7 sevens then, because we can't have 6 sixes on this Whisper 5 line. So that's 7, which makes, and that's 7. That leaves these a 7, that's a 7, and this is a 7, which eliminates 7 and the rest of the possibilities here. 1 eliminates 1 here, so that's 2 and 1. This can't be 1 or 2, it's 3. That means whatever must here must be appear 3 times, which means it must be a 3 there. So this also must be 3. This cannot be 3 here. 3 eliminates 3 here, so that's 2, which means this can't be 2. That's 3. There's no 3 here. This digit is next to 2 unique digits on a Whisper 5 line and can't be 7 or 8, so this has to be 9. This has to be 8 or 9 here because it can't be 7 or 6. This is next to 2 unique digits on a Whisper 5, next to 3 on a Whisper 5 line and can't be 8 because of 8 in the row. Also, 3 eliminates 3 here, so it's 5. And that makes that a 3. Therefore, this must be 9. That means this can't be 8 or 9 here. It's next to 2 unique digits on a Whisper 5 line, so it must be 7, which can only be next to 1 and 2 on the Whisper 5 line. That eliminates 1 and 2 on the rest of the column. This can't be 1 or 2. It's 3. So 2 has to appear 3 times on the Whisper 5 line, and the 3 must appear 2 times on the Whisper 5 line here. So this must be 2 because we have 1, 2 here and 1, 2 here. So that makes this a 1. This can't be 1 or 3, so that makes that 2. 2 cannot be next to 6 on a Whisper 5 line, so this is 8. And we have 3 next to this digit next to 3 on a Whisper 5 line. It can't be 8. It's therefore 9 here. This digit is next to a 3 on the Whisper 5 line, and it can't be 9 because of 9 in the row, so that's 8. Okay. Remaining digits in row 4 are 5, 8, and 9. 8 can't be either of these, so 8 has to be there. This can't be 9 because of 9 in the column, so it's 5, which makes that 9 there. Okay. This is the last high digit here, and it cannot be, this has to be a 4, 6 pair here. This can't be 4 because of 4 in the row, so that's 6 and 4, which forces this to be a 9 there. Okay. Where is 2 in box 4? Can't be here because of 2 in the column, can't be here because of 2 in the column, so 2 has to be here. Oh, yeah, 2 eliminates 2 here, so that's 1, which makes this 2, which makes that 1. That eliminates 1 there, so it's 2 and 1 there. 1 eliminates 1 there, so that's 2. Okay. So where's 1 in column 2? Can't be here because of 1 in the box, can't be here because of 1 in the row, so 1 is there. And we have 8 ones. We know where the last 1 is, it's there. 2s. 2, 3. We have 9 2s. 3s. In column 8, 3 cannot be here because of 3 in the row. The rest are filled out, so 3 is there. We don't actually have enough information about 3s to eliminate all possibilities here and here. Okay, 4s. 4 in the central box, box 5, cannot be here because of 4 in the column, so 4 has to be one of these two, which eliminates 4 as a possibility here. That leaves 4 remaining there. 4 then in column 2 cannot be here because of 4 is in the boxes, and therefore must be there. 4 in box 8 cannot be here because of 4 in the row, so 4 has to be there. So we have 8 4s, so we know where the last 4 is. It's there. 5, we don't have enough information about. Well, okay, column, row. Where is the 5 in box 8? It has to be one of these two cells. So that eliminates 5 as a possibility here for box 9. This 5 eliminates 5 as a possibility here. So where's the 5 in box 9? It must be there. We don't have enough information for the rest of the 5s, though. So let's continue. 6s in column 8. 6 has to be there. That means in column 3, 6 can't be here because of 6 in the row, so 6 must be there. Where is a 6 in column 2? It has to be there, which means the 6 in column 6 must be there. Well, where is the 6 in box 2? Can't be here because of 6 in the rows, can't be here because of 6 in the column. So 6 has to be there. That gives us 8 6s, so we know where the last 6 is. It's there. 7s, we have all 9 7s. 8s. 8 in box 2. Cannot be here or here because of 8s in the rows and columns, so 8 has to be there. In column 7, 8 has to be there. It's the last remaining digit, which gives us 8 8s, so we know where the last 8 is. It's there. 9s, we have 1, 2, 3, 4, 5, 6, all the 9s, so the ones left are 3, and the 3 remaining in column 5 cannot be here because of 3's in the column, or 3's in the boxes, so 3 has to be here, which makes that 5, which makes that 3, which leaves the remaining digits as 5s. So that's how you solve it. Yeah, I was kind of curious about how this would play out. This is the first time I've seen a rule set like this, and I was interested to see how that would work. It is rather restricting, so it's not necessarily one that we probably will see that much more of, but it was an interesting concept. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.